this video, we are going to solve all the 6 questions of exercise 1.2. So let's see the first one. We have to express each of the following numbers using prime factors, right? So there are two ways to represent numbers in prime factors. I'll explain the two ways. So first one we'll do in the two ways. Second and the fourth one we'll do in the first way. Third and the fifth one we'll do in the second way. So first, now 140. So first one is, we have learned this since our childhood. So 140 can be written as 2 into 70. And 70 can be written as 2 into 35. And 35 can be written as 5 into 7. So 140 can be written as 2 into 2 into 5 into 7. And the other method is prime factorizing it. So 2 into 70, 2 into 35, and 5 into 7. Simply 140 is equal to 2 into 2 into 5 into 7. But we are asked to prime factorize it, so we must not use this form. We should only use this form. Okay, it will be easier, a lot easier when we do the examinations. It will be the easiest way and the shortest procedure to find. So the second question, 156. 156 can be written as 2 into 78, and 78 can be written as 2 into 39, and 39 can be written as 3 into 13, and 13 is your prime number. So 156 is equal to 2 into 2 into 3 into 13. Now let's do the third sum. What is third sum? 3825. So 3825, prime factorize it. It is not divisible by 2, so next prime number is 3. So 3825 divided by 3 is 1275. Again, it's not divisible by 2, so 1275 divided by 3 is 425. 4 to 5 is not even divisible by 5. 3, I mean 3. So next prime number is 5. So 4 to 5 divided by 5 is equal to 85. Next, 5 17s are 85. 17 is a prime number. So 3825 is equal to 3 into 3 into 5 into 5 into 17. Now the fourth one. What is fourth one? 5005. So it can be written as 5 into 1001. This can be written as 7 into 143. And this can be written as 11 into 13. So 5005 is equal to 5 into 7 into 11 into 13. So the last one, it's a pretty hard sum. 7429. So its sum is 7429. It can be written as, it is not actually divisible by 2, 3, 5, 7, 11, or 13. So the first prime number which is divides 7429 is 17. So 7429 divisible by 17 is 1437. And 1437 is neither divisible by 17 also. So it is divisible by next prime number, which is 19. And 1437 divided by 19 is 23. So 7429 is equal to 17 into 19 into 23, because 23 is also a prime number. So this is how we prime factorize different numbers. We can use both of the ways. Both of the ways are correct, but the second way is pretty easy and very, it doesn't take much time. Next one, we have how to find HCF and LCM of different numbers by prime factorizing them. So let us see. We have numbers as 12, 15, 21, 17, 23, 29 others. So we'll prime factorize them and find the LCM and HCF one by one. So first one is 12, 15, and 21. Prime factorization of 12 is 2 times 6, and 6 is 2 times 3. So 12 is equal to 2 into 2 into 3. And 15 will be 3 into 5. 3 into 5. And 21 will be 3 into 7. So if you have watched my previous videos, HCF is the common number in all the three prime factorizations. So it will be 3 because it is the common one in all the three prime factorizations. Next LCM will be first step, write all the numbers present in the prime factorizations 2, 3, 5 and 7. We can see two 2's here, so 2 power 2, 1 3, so 3 power 1. You may ask me, there are 3 3's here, why don't we take three threes? We should choose the number which is present in the maximum times of the number. The digit should be the maximum number of times, and keyword is in each prime factorization. So we'll take 3 one time, 5 one time and 7 one time. So it will be 4 into 3 into 5 into 7. 4 into 3 will be 12 into 5 into 7. 12 5 is 60 and it will be 420. So HCF is 3 and LCM is 420. Next one, 17, 23 and 29. We know that all of the three numbers are prime numbers. So 17 is equal to 17 into 1, 23 is equal to 23 into 1 and 29 is equal to 29 into 1. So HCF is equal to the common number which is present in three prime factorization. So it will be 1 and LCM is equal to step 1. Write all the numbers 17, 23, 29 and 1 and each of them are present in one time. So we'll multiply all of the numbers to get the LCM of the given numbers. So 17 into 23 is actually 391 and 391 into 23, if I remember it correctly, 391 into 29 will be 11,339. So HCF is 1 and LCM is 11,339 of the second sum. Third sum we have 8, 9 and 25. So 8 will be 2 cubes, so 2 into 2 into 2. 9 will be 3 square, so 3 into 3. And 25 will be 5 square, so 5 into 5. HCF will be the common number which is present in all the three prime factorizations. So we have no common number which is present. So HCF will be 1. Next, LCM, first step, write all the numbers. 2 into 3 into 5. Maximum numbers we can see is number of 2's is 2. 2 is 3 and 3 is 2 and 5 is 2. So it will be 8 into 9 into 25, which is 72 into 25. And if I remember it correctly, 72 into 25 will be 1800. So LCM will be 1800 of 8, 9, 25 and HCF will be 1. Next, fourth sum is a little tricky, but let's still do it. So the next numbers are 72 and 108. So prime factorization 72 will be 2 into 36, 2 into 18, 2 into 9 and 9 is equal to 3 into 3. So 72 is equal to 2 cube into 3 square. And next 108 will be 2 into 54, it will be 2 into 27, 3 into 9 and 3 into 3. So 108 will be 2 square into 3 cube. So HCF is equal to the common numbers which are present in both of them. So we have 2 2's common here and 2 3's common. So it will be 4 into 9, 36. We can see here the expansion of this is, let me write the expansion, 2 into 2 into 2 into 3 into 3, and this will be 2 into 2 into 3 into 3 into 3. We have 1 2 common, second 2 common, 1 3 common, and second 3 common. Okay, I hope you understood. So LCM will be write all the numbers which are 2 and 3, and maximum number of times 2 has repeated in both of them is 3 times. And similarly 3 also has repeated 3 times. So it will be 8 into 27, and 8 into 27 is 260. So let's do the last one. 306 and 657. 306 and 657. So prime factorization of 306 is 2 times 153 and 3 times 51, 3 times 17, and 17 is a prime number. So 306 will be 2 into 3 into 3 into 17. Next 657 will be next, right, 3 into 2, 1 and 9. Next again 3 into 73, and 73 is a prime number. So 657 will be 3 into 3 into 73. So the HCF is commonly repeated numbers which 1 3 and second 3. So 3 into 3 will be 9, and LCM, step 1, write all the numbers 2 3 17 and 73. 2 has repeated 1 time, 3 has repeated 2 times, 17 has repeated 1 time, and 73 1 time. So it will be 2 into 9 into 17 into 73. 2 into 9 18, and 18 into 17 I guess 306. So let us write it at 306. 306 into 73, it will be, into 73 will be 22,338. 22,338. So LCM is, LCM of 657 and 306 is 22,338, and HCF is 9. Next one is third question, which is check whether 6 power 9 can end with the digit 0 for any natural number n. So they're asking if we put any natural number n, we should get a 0 after multiplying it the number of times. So for example 10 power n, let's take 10 power n. So you put any number in n, for example n is 1, you get 10, n is 2, you get 100. So it ends with a 0. So what is the condition for any number to end with a 0 for natural number n with power n? So the condition is the prime factorization of it should have or should contain the numbers 2 and 5. So 10 power n, or we can write it as 10, which can be written as 2 into 5, or 10 power n, which can be written as 2 into 5 whole power n. So the prime factorization of the number should contain 2 and 5. While we check 6 power n, it only contains 2 and 3, or 6 power n is equal to 2 into 3 power n. It does not contain any 5, means it only contains 2. So we can say that for any natural number n, 6 power n can never end with a 0. You can write, so 6 power 1 is 6, 6 power 2 is 36, and so on. So this is how we do it. Next question, fourth one we have is, we should explain if these two terms and these two terms, product and sum, are composite numbers or not. So let's check the first one. The first one is 7 into 11 into 13 plus 13. As we know, terms are divided by plus and minus, And if there is division or multiplication between terms, they are the same term. So these all three digits are one term, and this is one term. Let's take 13 common from both the terms. So we get 17 into 11 plus 13, sorry, plus 1. It will be plus 1. Next, it will be 13 into 77 plus 1. It will be 13 into 78. We know 78 we can write it as 2 into 39, and 3 is a 3 13 is a 39. So it can written as 13 into 3 into 2. And we know by FTA, fundamental theorem of arithmetic, which states that every composite number can written in the product of primes. So we can see 13, 3, 2 all are prime numbers. So obviously these two terms, sum and product, is composite. So next, let's see next sum. It is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So this whole thing is one term and this is one term. Let's take 5 common out. Then we'll get 7 into 6 into 1 into 4 into 3 into 2 into 1 plus 1. Then we'll get, if we multiply, we'll get 1008 and plus 1. So it will obviously be 5 into 1009. And if I'm not wrong, 1009 is a prime number. It is not neither divisible by 2, 3 or 5 or 7. So 1009 is a prime number. So 5 and 1009 prime numbers. And again, by fundamental theorem of arithmetic, composite number can be written in the product of primes. So obviously, these two terms, this product and sum, is obviously composite number. So we have explained why these both terms are composite.
Fifth question is similar to fourth question, and we should show that
17 into 11 into 2 whole plus 17 into 11 into 5 is a composite number. So similar to the previous sum, let's write it down. 17 into 11 into 2 and 17 into 11 into 5. So when we see this kind of sums, we should see which numbers are common in both of the terms. So the numbers which are common in both of the terms are 7 and 11. So let's take 7 and 11 common out of the two terms. So we'll get 17 into 11 in brackets 2 plus 5. So it will be 17 into 11 into 7. And like the previous sum, we know that FTA is fundamental theorem of arithmetic. Meaning of fundamental theorem of arithmetic is a composite number can be expressed in the form of product of primes, or we can say it as product of primes is always a composite number. So we have got 17, 11, 7, which are prime numbers, and therefore the given question or the given two terms obviously is a composite number. I hope you understood the sum. Next sum is also very easy one.
sixth question.
So the question is, which digit would occupy the units place of 6 power 100? So for this sum, let's check the periodicity. So 6 power n. So 6 power 1 is 6, and 6 power 2 is 36. Next, 6 power 3 is 216, and so on. So if we check even 6 power 4, which is 216 into 6, we can see that 6 is 36, and it always ends with a digit 6. So any number for n in 6 power n and the units place will always end with a 6. So that is the answer. Which digit would occupy the units place of 6 power 100? The answer is 6. So
Hope you understood the questions in the video. For more such content, you can check out the description. We have different playlists of for different exercises. Subscribe for the new ones. Thank you.